and as you're adding electron, adding proton simultaneously, the distance between the positively charged nucleus and the valence electron becomes what? Closer as a result of what? Contraction. So such an electron, and so therefore the attraction is now what? More. So to knock off such an electron would require what? A higher amount of what? Energy. Therefore, it will definitely increase. It increases across the period. Also, electron affinity. That is the energy required to add this time around. In ionization energy, you are removing an electron. But in electron affinity, from the word affinity, affinity means what? Loving. Is electron loving. So the electron affinity is the energy required to add an electron to an atom in a gaseous state to form an atom in gaseous ion. So as you are moving down the group, what happens? Electronegativity decreases, electropositivity increases. So what it means is that as you are moving down the group, since electropositivity increases and electronegativity what? Decreases. As you are moving down the group, what happens is there is that as you are moving down the group, it is the electropositivity that is on the increase. And since that shows that affinity for electron is what? Lesser as you are moving down the group, since it is the electropositivity that is on the increase. So affinity for electron becomes what? Lesser. So that means it definitely what? Decreases. As you move across the period, due to increase in nuclear charge, what happens? There is a continuous addition of electron. And since electron affinity has to do with the addition of electron, automatically, as you move across the period, electropositivity decreases, but electronegativity increases. And since electron affinity has to do with the affinity for electrons, so automatically it will definitely what? Increase. It will increase. So it increases. Then electronegativity. Down the group, electronegativity is the ability of an element to attract electron to itself. So in this regard, that means that as you are moving down the group, electronegativity what? Decreases. Electropositivity increases. So that means as the electronegativity decreases due to the fact that the tendency to acquire electron or to gain electron is less. The tendency to gain electron is the tendency to lose electron or to accept electron decreases because electropositivity what? Increases. So automatically electronegativity will definitely decrease. It decreases down the group. And across the period, as you move across the period, the electronegativity increases simply because the tendency to accept electron also what? Increases. So automatically electronegativity increases across the period. So by virtue of this explanation, I'll be able to explain how all these properties of elements down the group and across the period are able to what? Respond. So I'll be able to use these parameters to relate their response down the group and across the period. Having explained the variation in properties across the period, then another objective is to differentiate between different types of bonding. So we have different types of bonding. One, electrovalence/ionic bonding. We have covalent bonding. Then we have coordinate covalent bonding. Then we have the one that is also known as what? Dative. It's also known as dative. Then we have metallic bonding. Then we have hydrogen bonding. Then we have others that are what? Intermolecular forces. We cannot classify them as bonding. Forces of what? Attraction. Attraction, where we'll be talking about metallic. Okay, we also have under this one, we have metallic bonding. Let me say this one is also metallic bonding. Metallic bonding. Then we have intermolecular forces of attraction, which we can talk about van der Waals forces. Van der Waals forces. So these are the notable ones that we have. Then electrovalent or ionic bonding. So in electrovalent bonding, which we ought to have learned in our previous lessons, I just want to summarize. In electrovalent bonding is a bonding that occurs between a metal and a non-metal. And sometimes, because this is UTME and they can afford to stretch you more than your limit. Also, there is a scenario where metal can exist in two forms. Like, let's say this is our halogen. So you can have MX2, you can also have MX3. That is a particular metal forming more than one compound with what? An halogen or a halogen. Such is also known as what? Electrovalent or what? Ionic bonding. Take note of that. So in electrovalent or ionic bonding, it has to do with what? The transfer of an electron from a metal to what? A non-metal. So a metal is the donor, while a non-metal is the acceptor. So there is a kind of transfer to attain octet or duplet structure to ensure what? The stability of the compound. And that is the significance of what? Atomic structure. Every compound or every element is working towards what? Stability. Now, you have covalent bonding. In the case of covalent bonding, in the case of electrovalent, there is a transfer. It has to do with transfer. But in the case of covalent bonding, it has to do with what? The share of a pair of electrons between the two participants or the participating species. So that means there is what? A share of a pair of electrons. And a typical example of that is if you have an atom X having one electron, I have another atom Y having electron. So the way they will combine is, this is your atom X, this is your Y. So if they want to combine, you have them combining this way, such that you have your Y, then they have now they share. So this one is a contributor of one electron, this one is a contributor of the other electron. So they now share this way. If you see this kind of scenario, then you talk about what? Covalent bonding. Then in the case of coordinate covalent bonding, you know that it is an extension of covalent bonding. But the major difference between coordinate covalent bonding and covalent bonding is that in the coordinate covalent bonding, the share is donated by one participant. You can see that in the covalent bonding, the share is donated by what? The two participants are the donors of what? The electron, so that they can now what? Interact. But in the case of coordinate covalent bonding, the shared electron is donated by only one of the participating species. So that means in the dative bonding, a typical example of that is the formation of ammonium ion and hydrozonium ion. So in this regard, we discover that here you have the combination of ammonia plus a deficient hydrogen. There is a lone pair on this that it will use to pair up with this. You can see that means that, and that was what I was trying to tell you, that in coordinate covalent bonding, the shared pair is donated by only one participant. This one is what? Deficient of electron. This one is not having electron. This one is not having any electron. So before they can combine, this one has to donate this lone pair. But in the case of covalent, one is bringing and the other is bringing. So both of them, they now share the electron. Also in the case of hydrozonium ion, your water plus a deficient hydrogen. Water has lone pair. So this lone pair will pick that up. So this still boils down to the fact that it is one participant that is donating the electron that they are sharing. So that is what is known as what? Coordinate covalent combination or bond. Then the metallic bonding. In the metallic bonding, the force of attraction between the valence electron and the metal atom. So it means the bonding is as a result of what? The force of attraction between the valence electron and the what? The metal atom. Take note of that. So the interaction is as a result of what? Valence electron and the what? The metal atom. Then the hydrogen bonding, it has to do with the bonding between a hydrogen and a highly electronegative element, such as the bond that is existing in hydrogen fluoride. Take note of that. Where hydrogen is, this is the hydrogen and this is the what? Highly electronegative element. Take note of that. That is metallic bonding. Okay, metallic bonding is stated here already. So we have hydrogen bonding, so this one is no longer there. Since it's stated, that's tautology, I have it here already. Then the van der Waals forces. This one cannot be classified as bonding. This one is